So what quadrant do you draw your triangle in for this first one? 4, good. For sine inverse, it's either 1 or 4, and since it's negative, it's going to be 4. Sine is the y value, so that negative a half goes here. Other side, square root of 3 over 2. Okay, perfect. A half is the little side, so what is the little amount of pi that would go across from you? Yes, pi over 6. Your answer's not pi over 6. You had to rotate backwards to get there. So your answer is negative pi over 6. Do you want me to do B as well? And then I'll pause the recording and you can try C and D? Okay. So this one's also negative, so it can't be quadrant 1. Cosine, though, is even. So which quadrant is it in for that one? Good. Quadrant 2. Cosine is the x value, so that goes here. And then your other side, square root of 3 over 2. So square root of 3 over 2 is the bigger side. What is the amount of pi? Like, you would not want to eat this amount of pi. It's too much pi. It's too big. Yeah, pi over 3. You do not want to eat a third of a pi. That's bad for you. Now, your answer is not pi over 3. It's 2 pi over 3. It's how much you rotate it to get there. Good job, guys. The denominator's not going to change. So if you kind of let your instinct kick in, you know it's going to be thirds, 2 pi over 3. So go ahead and try C and D, and then I'll go over them for you. So for this one, is either square root of 3 over 2 over a half, or a half over square root of 3 over 2. It's in quadrant 1 since it's positive. But out of those two options that I just said, which one reduces down to this? Yeah, it's 1/2 over square root of 3 over 2. So go ahead. Can you give an example of what you'd like to flip? Yeah, this would just say square root of 3 would be the other choice. There's only so many options. You're very limited, okay? But if you cancel these 2's, you get 1 over square root of 3, which rationalizes to be this. All right, tangent is what over what? Y over x. So y is the 1/2, square root of 3 over 2 is the x. Again, if you got it backwards, I would take off like a point or a half a point or whatever, and then read with you. So what is your angle across from the 1/2? Pi over 6. And if you're in quadrant 1, that is just your answer because you didn't rotate far enough for it to be anything different. All right, what did you draw for the last one there? Good. Sine is the y value. So up, down, left, or right, where is the y value? -1. Down. 0, -1. Now, if you wrote 3 pi over 2, I get why that happens. But remember, these quadrants don't exist. It's like the bridge is washed out and you can't get to the other side. You have to rotate backwards to get there. So it is going to be negative how much? 2. Good job. Negative pi over 2. All right. That's what we did last time. Just reviewing it. Moving forward, and we have done this before, are your application problems. So see how this has like a story down here? And we're going to do these 2 first. You're going to do 3 decimal points for this, and we're going to need a calculator. So let me share my screen really quick. You need to be in what mode for this? This is degrees, okay? So I'm going to hit this little wrench over here, look it, and I'm going to change this to degrees. If you don't change that, literally everything is going to be wrong, okay? Let's go ahead and draw ourselves a right triangle. It doesn't matter where A and B go, but C has to be the right angle. So I labeled mine like that. Again, the A and B, if you swap them, that's fine. So baby A is 4. That goes here. Do you remember this, how they go across from each other? Cool. And baby B is 9. And we don't have to find C. It doesn't say to find that. What do the directions say to find? It doesn't say find the other side. It says find the angles. Okay, so let's find A first. You are here on the map. You know the star that's like you are here? That's your point of view. Okay. What is the opposite of A? 4 is opposite and 9 is adjacent. SOHCAHTOA, that's tangent, opposite and adjacent. So it's tangent of A equals 4 over 9. And again, we've done this before. I don't like how I wrote tangent. That looked messy. I'm going to fix it. Sorry. Is anybody else like that? Like it'll bother you? Okay, thank you all my type A people out there. I know half of you are like, we don't care. I had to fix it. All right, does anyone remember how to type that in the calculator at angle? It's tangent inverse. I know what you mean by negative. Do you remember how to get that? Go in here, functions, and it's conveniently like the very first thing that up here, tangent inverse 4/9. And we want 3 decimal points. If you're in the back, I know it's a little bit small, but it's 23.962 degrees. And you can truncate that. So 23.962 degrees is A. Now you can get B without doing a whole bunch of extra work, because what do all the angles of a triangle add up to? They add up to 180. And if this one's 90, that means the other two have to add up to 90. So watch me do this. I'm going to share my screen again so it shows up on the recording. I'm going to do 90 minus, then I'm going to copy paste that answer. Yeah, I did that. Control C, Control V. You guys grew up with computers. You know how to do that. Because the whole triangle adds up to 180, but 90 was the right angle. So there's 90 left for the other two. I heard somebody else say, wait, so go ahead. You can do that too. Okay, so, or you can do this. A equals that, it'll store it. You can do 90 minus A. That works too. Yes, so B is 66.037 degrees. Good call. I'll do it that way from now on, the storing, because then I won't have to copy paste. But you get the same thing either way. Let's try it again. Go ahead and draw a right triangle. Again, it doesn't matter really where A and B go. I did it the same way I did the first one, just for consistency's sake. Little c is 12.9 and little b is 5.3. We don't have to find little a. You could do it. How would you find a? Let's just verbally go over that. Pythagorean theorem, you could if you wanted to, but the directions don't ask for that. All right, so let's find a first. You are here on the map. I don't have the opposite. All right, 5.3 is adjacent, 12.9 hypotenuse. So it is cosine. Good job. So cosine of A equals adjacent over hypotenuse. Isn't that nice? So how am I going to type into the calculator? Cosine inverse. Yeah, I'm going to go into functions. Cosine inverse of, let me get rid of that. 5.3 divided by 12.9. Truncate that to 3 places, and it is 65.741 degrees. And then to get B, same thing. I'm going to go over here and write A equals. And then what will I type in the next one down? Yeah, 90 minus A. It is 24.258 degrees. Great. A child is flying a kite. Do you have an imagination? You have to have an imagination for this. Oh, yes, ma'am. I have an imagination. All right, draw yourself a right triangle. Child is flying a kite. The string is 17 meters long. Where does the 17 go? The hypotenuse. You have to imagine the kid is down here and the kite is up there. That's the best I can draw that. So, and you don't even have to put that on there. I'm just trying to help you visualize. All right, the kite is 10 meters up in the air. So where does the 10 go? Yep, on the left, the vertical part. What is the angle of elevation from the child on the ground? So this is the value that you're looking for. I'm going to call it X. You can call it whatever you want. Call it theta. Usually we use theta for angles, but I'm using X because that's what we're looking for. Sine, cosine, or tangent. What do you think? Sine. We have opposite and hypotenuse. So sine of X equals 10 over 17. And I am going to type sine inverse. Did you guys notice how I clear it out every time that I start a new problem? I'm in the habit of doing that so you don't get cluttered and forget what you're looking for. The sine inverse 10 over 17 is 36.031. Now listen real quick. For story problems, you need units. It's required, and I'll take off if you don't plan. Units are degrees. So that symbol, even though it's really tiny, is very, very important. Some people feel like, oh, if I want to be like sure that I put my units, you can do this instead if you want, like write it out as a word if you're like, I just want to be extra sure that I did it. But you have to put something there. And if you're looking for the angle, it's not going to be feet. Angles aren't in feet. Okay. The plane is flying 20,000 feet in the air. In your triangle, well, I just drew a horrible triangle. Let me fix that. Where is the 20,000 going to go? Vertical part. That's how far up the plane is in the air. And I am not drawing very well today. All right, so in our right triangle, the 20,000 goes there. The horizontal distance, that kind of spells that out for you. That's going to be along the ground. From the airport to the place directly below the plane is 5,000 feet. So very much not to scale.
No.
What is the angle of depression? I don't care whether it says elevation or depression. Do you remember how in theory, even though the earth is round, the sky and the ground are parallel? Where do you put X no matter what? The bottom. That is where that goes. You can dot in the sky if you want and do the alternate interior angles thing, but that's where it goes. All right. Sine, cosine, or tangent? This tangent. Good job. You have opposite and adjacent. So tangent of X equals 20,000 over 5,000. And so when I type it, and this is basically draw a picture, set it up, type it in. There's 3 steps to this. All right. I'm going to type tangent inverse. You can go ahead and move right there. Now, thank you. You'll be next. 75.963 degrees. And make sure you put the degrees because those are your units. I always preface questions with that. Because we're using inverse functions to find them. And this unit 11, is on inverse functions. But it's kind of hard for me to teach it way back when without going over it. So we have sort of already done it. Like, why would I put these questions off until now? So I teach it to you before, and then when we get here, it's super easy, and everybody's like, yay. No, this is it. This is it.
Like, this isn't like.
What we did before was a stepping stone to this. I just already taught it.
Just this.
I just don't see a point in not showing you ones like this when we're doing word problems before. So I throw them in there, and then I do that on purpose. So when we get here, everybody's like, oh, this was real easy. Like, we've done this before. Let's try it again. A hot air balloon is tied to a stake in the ground. Now, because of like wind and stuff, the hot air balloon isn't going to be right over top of where it got tied in the ground. It's going to be like the kid with the kite string. Do you get what I'm saying? Like, it's tied to the ground, but it moved. All right. The rope is 150 feet long. Don't label that yet because we're going to have a conversation. The horizontal distance that's going to be along the bottom is 23 yards. You should go, hey, wait, hold on a second. Something should be like, hey, that's not right. You have feet and you have yards. Now, listen, it doesn't matter if you change them both to feet or change them both to yards. Makes no difference, but they have to be the same. The reason it doesn't matter is your units for the final answer aren't going to be feet or yards. They're going to be degrees. Okay. Do you want to change to feet or do you want to change to yards? Sounds like feet wins. I had to pick yards because it makes the number smaller, but that's okay. We can go feet. Next question. Nope, feet. You said feet. So
I said yards.
Okay. It's not really going to matter. We have a calculator. Okay. But feet makes the numbers bigger. Yards makes the numbers smaller. Do you know how many feet there are in a yard?
3.
3. You could have given it a guess. 3 feet in a yard. So to turn those 23 yards into feet, we're going to do 23 times 3. So 69 feet. Now we're going to go ahead and label. So where does the 150 go? That's the rope. So that would be which part? Hypotenuse, good. I was waiting for someone to give me some vocabulary there. And then we were told this was the horizontal part, so they kind of spell that out for you. What is the angle of elevation? So X goes right there. So sine, cosine, or tangent is the next question. It is cosine. We have adjacent and hypotenuse. So cosine X equals 69 over 150. And I'm gonna go and type in cosine inverse. And it is 62.612 degrees. Can you see past me? 62.612. I know I like to show you the calculator, but I know it shows up small. Try to zoom in on the calculator before too, and it doesn't really work. So let's try and say it verbally for everybody. All right, a boat is being pulled in to the dock. And the winch is like the thing that reels it in, right? 10 feet above the water. So where do you think the 10 is going to go on your triangle? Vertical part. You have to imagine like this is the water, the boat's in the water, and like I can't draw a crank, like the thing that wheels it in, but it's like on a, yeah. Anyway, what is the angle of elevation? That's going to go here. 26 feet of rope out. So the rope connecting to it, that would go right there. So sine, cosine, or tangent? Sine. Good. So sine of X equals 10 over 26. And again, your units aren't going to be feet or meters or yards or whatever it was. Your units are going to be degrees. Again, clear this all out before you start each time. 22.619 degrees. Do a little extra into this last one to make it a bit more interesting. Or wait, question? Are we okay? So I'm going to read the whole thing before we start drawing. A hiker looks up to the top of a mountain. Angle of elevation is 33 degrees. You with me here? You get up to the top. This person hikes 15 miles up and then 17 down the other side. So they go up and then they go back down. Do you see how there's going to be two triangles? Following me there? Okay. So your picture is going to look like this. And there's going to be two right triangles, one on each side. Not to scale at all. Okay. So the 33 is going to go right here. We were actually given an angle in this one. You have to have an angle to get started for this one. So they hike 15 miles up the mountain. That's going to go right there. Where is the 17 going to go? Yeah, on the other side. And 17 down the other side. Mountains aren't going to be perfectly symmetric. What is the angle of elevation on the other side? So that one right there. So it's not perfectly symmetric. So it's not going to be 33. We're going to have to find the height of the mountain first before we can get this part. So it's going to be like a two-step problem. Go ahead. No, we're not. I get what you're saying with that. Or well, yeah, do you want to do law of sines instead? That's not really what I was thinking we would do, but we could, I'm seeing, well, I was going to show you what I think is the easier way. I didn't really expect anyone to remember that, to be perfectly honest with you. Yeah, that's what I was going to do. Okay. I can show you both. Believe it or not, I can do that.
Let's do that.
Yep. Okay. I need I don't know, but we're going to all have a positive attitude about it. Because what's the only other thing on our schedule today? Bingo. All right. Now I need a letter of the alphabet to call this. What do you want to call it? H. Okay, H for height. I like how you all agreed with that. Now we're going to look just at this side. Sine, cosine, or tangent? Sine. Good. It's going to be sine of 33 degrees equals height over 15. I like how you all agreed on H. You all like, you're super confident about it. Now, how would you type that in? Do you need an inverse? You do not need an inverse. Good. It's going to be what? Good. We're going to multiply over the 15. So it's going to be 15 sine 33. I did not need an inverse. Okay. And so H, the height of the mountain, 8.169. What? It's 8.169 what? Miles, good. That wouldn't be a mountain if it was feet. I mean, teeny little mountain.
It'll still give you like.
Well, we picked the letter of the alphabet. Any letter of the alphabet you want. We picked H for height, but it doesn't matter. I wouldn't go with S. S's look like fives, you know. But H for height was good.
Like when you put that into the calculator.
You're ahead of me, so can you just wait? I'm gonna show you. Well, did you look at what I typed in the calculator? Did I type an H? Is there an H anywhere in what I typed? No. However, look it, guys, because that's going to lead into the next thing. I want to store this as H. So do you see how I'm going to put an H equals out front? You can do that, or you could copy paste. All right. So now we're going to set up a second problem. We're going to look just at this side. Would we need sine, cosine, or tangent? Sine. So sine of x equals our height. Now you can write H or you can write 8.169. That's totally up to you. All right. Over 17. Now, do I need an inverse to type this one? Yes. Why? Finding an angle. I'm going to go down here and get functions, get sine inverse. All right, look it. I'm going to type H over 17. And that's your final answer. So it's 28.722 what? Degrees is your answer. Don't stop listening to me. You guys had a good question about what's another way that you can do this. And I'm impressed that you guys even thought of it. So you can do law of sines. Do you remember if you have a side across from an angle, you can set up law of sines? What's the side across from an angle that we have? Yep, so you could do 17 over sine 33. If you're like, nah, I don't feel like paying attention to this, it's going to be on the final that you all have to take. So probably write this down. I am not performing for you. Okay. 17 over sine of 33 equals, and then line it up the other way, 15 over sine of x. Is it coming back to you? I'm glad you guys brought this up. I'm going to make my other class do this too. Now, do you need inverse? Yes, because you're looking for an angle. So watch me type this. Here, let me clear all this out. I'm going to get sine inverse. Then you cross multiply and divide. So it's going to be sine inverse, and then I'm going to type what? Yep, 15 sine 33 over 17. We should get the same thing. Do we get the same thing? Pay us 28.722. It just depends on what you remember. Do you remember SOHCAHTOA or did you remember law of sines? This is actually quicker to get the same answer, but they both work.